Okay, in this problem, we want to find the equation of a tangent line. We know how to do that. Find the equation of a tangent line, we need the slope. Derivatives give us slopes of tangent lines. So we're going to need the derivative. So we want f prime of x. Now, if you memorize chain rule in terms of f's and g's and f primes and g primes, you're going to have a bad day. Don't memorize it like that. What I want you to think when it comes to chain rule, you've got some outside function evaluated at some inside function. You got a function inside a function, and you're trying to take that guy's derivative. Then you take the derivative of the outside, leave the inside alone. This is not times. That right there is of. Then multiply by the derivative of the inside. That's the way I want you to think of chain rule. If you think in terms of f's and g's, you're going to get confused because this guy is already f. So here, this is my inside. Basically, whatever's in your grouping symbols is the inside function. And what am I doing to that? What is the outside? Here, I'll write this, x squared minus 2. The outside, what am I doing to that? Is I'm taking junk and cubing it. I'm cubing that guy. So the derivative of that, the derivative of junk cubed is 3 times junk squared. The 3 came down and now became a 2. But now I'm not writing x here, I'm writing x squared minus 2. So that's derivative of the outside evaluated at the inside times the derivative of the inside. What's the derivative of x squared? 2x. The derivative of minus 2 would just be minus 0. I mean, I could write minus 0, but that's just 2x. Okay, there's my derivative. Now, what do I want? I want f prime at negative 2. So that would be 3 times negative 2 in parentheses squared minus 2 squared times 2 times negative 2. So that'd be what? 3. That'd be 4 minus 2 squared. So 4 minus 2 is 2 squared. That'd be 4 times negative 4. This is all multiplied here. So I think that's negative 48. So that's the slope of my tangent line. Now, in order to find the equation of the line, we want y minus y naught equals m x minus x naught. Point slope form is by far my favorite. You know, if we were in a college algebra class, I would never be happy with you leaving an answer like this. Like the directions would even say, write your answer in slope-intercept form. By the time we get to calculus, nobody cares about that. Like you might have some homework questions that want slope-intercept form, but anything written, I'm always going to be okay with this. Especially once we get some nastier numbers later, like it's just so much easier. We know x naught, negative 2. I know m, negative 48. I just got to find y naught. Here's where mistakes happen. Y naught, you don't get by doing this. That's how we found m. To find the original y naught, you plug that same x value into the original function. So that'll be negative 2 squared, 4 minus 2 cubed, which I think is 8. So then you guys can check all my arithmetic here. minus a negative would be plus 2 there. And this is a parenthesis. And that's a good place to stop.